Hello everyone. This is the first video for your Unit 4 Quadratic Functions section. First thing I want to talk about here is this first chart basically shows the general form of a quadratic, which is f of x equals ax squared plus bx plus c, where a, b, and c are all constants. And a cannot equal 0. If a equals 0, essentially all we have is a linear function, x plus 1. So it just creates a line. So a cannot be 0, or it's not a quadratic function. So I'm going to go ahead and skip that one where a is 0 and look at this first application where a is 1 and b and c are both 0. This is the basic form of the quadratic function. F of x equals x squared. So let's look what happens as we plug in these values for x into this function. So if I let x equal -2, that implies that f of -2 equals the quantity -2 squared, which is 4. -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So let's plot these points. So we have the point 0, 0, 1, 1, -1, 1, 2, 4, and -2, 4. So the graph looks like this. And down here at the bottom, it is not a hard edge. It is a round kind of edge down here. It doesn't do this type of thing. It does this type of thing, more of a curve. And describe this. So there is your basic graph, f of x equals x squared. All other graphs of quadratics are some form of this parent function, whether they get shifted up, shifted down, shifted to the right, shifted to the left, flipped over, or so on. Now let's answer these characteristic questions. The x-intercept, there's only one. It's right here at the point 0, 0. That is actually where the y-intercept occurs as well, because when x equals 0, y equals 0. The vertex is right here. That's the point where the parabola bottoms out or tops out if it goes the other direction. So the vertex of our graph is 0, 0. The axis of symmetry is the line that cuts this graph in half. Your axis of symmetry will always go through the vertex. So our axis of symmetry is this vertical line, which is the line x equals 0. Remember, vertical lines are always of the form x equals something. Horizontal lines are always of the form y equals something. In this case, since our graph opens up, we have a minimum value of, which occurs at the vertex 0, 0. So this max min will always be the vertex. You have to just determine if it's a maximum or a minimum value. Now let's look at the domain. So the domain is all x values that are assumed by this graph. Notice it's all real numbers. And the range is all y values, which starts here at 0 and goes up from there. So our domain, the x values, is -infinity to infinity. And our range is, it includes 0, so we put a bracket on it. Bracket 0 to infinity. All right? Now let's look at the intervals on which f of x is increasing. So remember, this is our x and this is our f of x. So the interval on which our f of x values are increasing is over here. Because look on the left side of the axis of symmetry, our f of x values are actually getting smaller. So our interval on which it increases is from 0 to infinity, which is this section over here. Notice over here, f of x is increasing. And then it decreases from -infinity to 0. So it decreases on this side. All right, and notice it does not include our 0 in the increasing or decreasing, because at 0, this graph is neither increasing nor decreasing. Let's look at another example. So this one is -1x squared. So when a is less than 0, So this function, f of negative 2, is actually negative 2 squared, which is negative 4. Here, when we plug in negative 1, we get back negative 1. Here, when we plug in 0, we get back 0. Here, when we plug in 1, we get negative 1. And here, when we plug in 2, 2 squared is 4 times negative 1 is negative 4. So what this does is it flips the graph over. So our graph of y equals negative x squared does this. Our x and y intercepts are still 0, 0. Our vertex is still 0, 0. Axis of symmetry is the same, x equals 0, but now we have a maximum value at 0, 0. And our increasing, decreasing intervals change, because now it's increasing on the left-hand side of the axis of symmetry, and then it decreases on the right-hand side of the axis of symmetry. So f of x is increasing over here. So from negative infinity to 0, and then it decreases from 0 to infinity. Our domain is still all real numbers, but our range changes. Now our range is just this area down here. So it's from negative infinity to 0, including 0. Well, what we'll see when A changes is this just widens the graph out. And this one narrows the graph, right? So you can plug these values in, but our characteristics are all going to be exactly the same as the first example. Now let's look at this graph. F of x squared plus 1. So what it's going to do is it's going to shift our graph up 1 unit. So when I plug in f of x, f is negative 2, I get the quantity negative 2 squared plus 1, which is 5. 4 plus 1 is 5. When I plug in negative 1, you get 2. When I plug in 0, you get 1. When I plug in 1, you get 2. When I plug in 2, you get 5. So now this graph goes through the points 1, 2, negative 1, 2, then it goes through 2, 5, and negative 2, 5. Like this. So our graph's been shifted up 1 unit. So now our x-intercept, there isn't one, there is none. This graph does not cross the x-axis. Our y-intercept is the point 0, 1, which happens to be the same as the vertex in this case. Our axis of symmetry is the same line, x equals 0, and now we have a minimum at our vertex, 0, 1. It increases from 0 to infinity, and it decreases from negative infinity to 0. Over here, f of x is decreasing. Over here, f of x is increasing. Our domain is all reals, or negative infinity to infinity. And our range, now our smallest value our range attains is right here at 1 and then goes up. So our range is bracket 1 to infinity. This one shifts the graph down 2 units, so it's gonna go through 0, negative 2, and go up this way. So notice this graph has 2 different x-intercepts. Now what happens when we have a b term? Notice here there is a 3x. That becomes a little bit more difficult to graph. And we'll find out in later videos exactly how to graph those functions. So, your post-class assignment, multiple representations, is due 7/18 at midnight. And then you'll have some turn-in portions where I want you to answer these questions in a Word file and email. All right? And your next video will start here at what's called the square root property. We'll actually learn how to solve specific types of quadratic. All right, thank you everyone and have a wonderful day.